Hello, welcome to session number 4 in the series Electrodynamics. And last time I have shown you one example of a microstrip line in momentum. Now it is easy to draw a 2D structure in momentum because all the drawing is in 2D. You do not have to visualize a lot in 2D when you are drawing in different layers, right? So there were no vias. We have not used vias at all. Now what we are going to do is we are going to simulate a CPWG, which is a coplanar waveguide with ground. So basically a line is surrounded on 3 sides with ground. Okay, so the 2 sides on the coplanar side, and then the bottom is the ground. So that's the structure of a coplanar waveguide with the ground, right? And what this surrounding the center conductor with the ground on 3 sides provides a much better control over termination of E fields, and then that means that the impedance is very well controlled, okay, over a large frequency band. So CPWGs are more often used in PCB designs, and there is another reason for that. If you see the structure, so we will just see the structure of that. So let me just first go ahead and make a new cell, a new schematic, right? And I call this as CPWG 50. So I'm making a 50 ohm CPWG line. So I will just say create schematic. And here I'm not going to draw anything in the schematic. What I'm going to do is I'm going to just call for a tool called line calculator or line cal. Okay. Now last time we had chosen MLIN, which is microstrip line, but this time we are going to choose CPWG. So that's CPWG. And if you see the structure, so the structure goes like this, that there is a center conductor which carries the signal. So it is of width W, and then there is a gap of width G, right? So there are two coplanar grounds, one on the left side, other on the right side of the line, right? And then also there is a ground underneath. So that is why it is called coplanar waveguide with ground. Now if I remove the ground part, then it will just be called CPW. So in this case, in CPW, the ground is not of much consequence, right? The ground is not there actually. Okay, so in that case the line is on left and right. The line is surrounded with the coplanar ground, while in CPWG there is a ground underneath also, right? Now let's say we are going to use the same substrate information. Okay, so epsilon r in this case was 5.85, right? And height is 97 microns, right? And the thickness is 9 microns. Okay, and the conductivity is 6.17 E7 Siemens per meter, right? And 10 delta is 0.002. So this is what this is there for borosilicate in a typical ferro LTCC process, right? Okay, so I'm going to design again. The line is at 10 gigahertz only, right? But now I have an independent control of the width of the line. Now in case of microstrip, if it is a lossless microstrip, it is the square root of L over C, which decides the characteristic impedance of 50. So basically if you make the lines wider, okay, that's going to reduce the L and increase the C. That means the characteristic impedance of a line will go down if you make the microstrip line wider. If you make the microstrip line narrower, then the L is going to increase and C is going to decrease. So that's going to make a higher impedance line. So that's basically what happens with microstrip line. Now in this case, again it is root of L over C only for a lossless line, but then the L and C can independently be controlled here. In microstrip line, it was just the height of the substrate which was fixed, so you could not control C independent of L. Now in this case, there is a coplanar ground, and this gap is much smaller than the height of the substrate, right? So in that case, you are able to design a coplanar waveguide with a certain width, right? So now let's say there is an option here. I can fix the width of the line, right? So let's say if I do this in mm, and I want to fix the width to be, let's say, 5 mm, okay, or 6 mm or 5 mm, for example. Okay, then this gap, okay, this gap is going to be computed for a given impedance of the line, and the length would be also computed. So let's just put the units right, and then let's say I'm trying to construct a 50 ohm line, and the length of this line is going to be 90 degrees electrical length. And when I hit synthesize, steam removed. Okay, I never encountered that error. Okay, let's see if I'm messing up something. 97 micron, 5.85, 6.15, 9 micrometer, 10 delta, length of the line. Okay. See, okay, so now, okay, it has to be very thin because it is out of the range. Okay, so let's say the line is 0. So if it is a 100 micron line, then it is 4 mil, and a boat technology you can do up to 2 mil, which is 50 micron, right? So here the width I'm going to keep as, let's say, 100 micron. Okay, fix this as 100 micron, and now the gap can vary. Okay, so what does it come up with? It comes up with the width is 100 micron, while the gap is 50 micron, and the length is 4 mm, which is going to be 50 ohm and 90 degree line. Okay, so you should have some rough idea of, what should be the width of the line, right? So you can get that rough idea from a microstrip design first. So if you have a microstrip design, now you go and proceed and do a CPW, so you have a rough idea of what the W should start with. You cannot just put here whatever you want and then try to create a line, because 5 mm is much larger than the height. So the golden rule is the gap and the width of the line is much smaller than the height. The height is 97 microns. Okay, so I'm putting width to be comparable to that, and then there is a gap which is computed, and the length for this 10 gigahertz. So let's try out this line. Okay, so what I'm going to do is I am going to make a copy of this, take a snapshot. Okay, so I have taken a snapshot of this, which I can use. So I'll keep this aside. I'll be able to close this. Okay, so no. So I have closed that. Now I'm in a position to do the layout of this line. Okay, so to do the layout, you can go to momentum. So you can basically just launch a layout of this CPWG, and that will launch momentum. Okay, so now the grid is already set. Okay, we don't have to set because we save that information in layout preference file. Okay, so now I need a 0.1 mm wide line, which is going to be 4 mil roughly, or less than 4 mil, right? But it is better than 2 mil, right? So now I am going to choose metal 7, and I can use the same trace if I like, and I can give the width to be 0.1, and I can have this truncated, rounded, fine. So I'm ready to draw that. So I'll start from here, Okay, and I will go for 4 mm to the right. So that's a 3 mm, that's a 4 mm. Okay, and you can double click it. So that's a line which is going to be the center conductor, right? So this is a center conductor line. Convert to trace. Still it's a trace unless I do a merge, I think. Merge union. Say okay. Okay, now it's a metal structure. Now what I'm going to do is I'm going to just copy this. So snap to the corner. So I have to snap by the corner. So I will make a copy of that. Okay, I moved it by mistake. So that's a copy. Okay, so I made a copy and I placed with this corner. So snap to corner is enabled. So I'm grabbing the line by the corner. You see, I'm making a copy, so I'm grabbing the line by the corner and it is snapping to this corner, right? So you see that this is done, right? So this one I have to move 49.99 micron, right? So if you see this one, it says 49.9, right? 0.049. Let's see this again. Sorry, 0.049, right? So I can say 0.05, right? So I would say edit, move, relative, y 0.05, and say okay. Similarly, this one will be minus. So I am moving them relative. So how do you move them relative? I'll show you once again. You select the object, you go to edit, move, and then you click on relative, and then you can punch in along y-axis or along x-axis how much you want to move. So that's how this is done. Okay, now here this dimension has no meaning to it. Like for example, I can make twice the size or thrice the size, right? So right now it is 0.1 micron, so I can make this bigger. So I can say edit, move. So I can always select the vertices also like this. So I have chosen 2 vertices and then I can move relative. So edit, move, relative, and I can move it by, let's say, 0.3 mm. So we have 0.4 mm on both sides. So if I measure this, okay, from here to here, this is 0.4 mm, right? Now you can do the same for this one, or you can just copy this. Okay, so you can just copy this from this corner and you can just place it over here and delete the previous one. Okay, so I have made them wider. Now the next thing which I can do is I have to add a ground on M6. So I'll just move to M6 and just draw a ground from this corner. So I have to snap to this corner and snap to this corner. Okay, so we are done with the structure of a line. Now I have to add the ports, but before that, these two are the grounds, coplanar grounds, and the red one is the ground underneath. So they have to be all combined using vias, right? So to do the via, what I'm going to do is I'm going to go 0.5. So I'm going to draw this on via layer. So this is going to be via 6, right? So via 6 connects metal 6 with metal 7, and here I just want to draw something which is 0.5 or 0.2. So I have to go 0.5, 0.4. That should be 0.5. Okay, so what I want to do is I want to place a number of vias from the left to the right. So this is only for measurement purposes. So I'm just going to make a copy of this and over here. And what I want to do is, okay, so now again the dia of the vias cannot be less than 50 micron, right? So what I will do is I will draw a line to guide me how to place the vias. So this is the line which is guiding me. Okay, so this is the line which is guiding me. Okay, so now I can start placing the vias. So I can choose a circular via. Okay, and that via is on via 6 layer, and this I can keep as 0.25. So 0.3 is another option, right? Why is it not letting me do 0.25? Okay, you can always go to insert coordinate entry, and I can do relative. So with respect to y I don't want to move, and with respect to x I can put 0.025 and say okay. Okay, so that's the first via which I have placed. Okay, the next thing I can do is I can just make a copy of this. Okay, and place it there itself and say edit, move, relative, and I can move it far to the right. So I can go by something like 0.5 mm. So that copy has moved 0.5 mm here, right? So now if I want to place one more, I can just say copy, and if I click here I made another copy over here. Now I can move two of them if I want. I can take this and then I can grab it from here. So I have basically grabbed these two and placed like this. So I have moved it, so I should make a copy of it. Sorry. So I am holding from here, so the gaps are going to be maintained. So I am placing these vias. Okay, make a copy of this and go here. Okay, so now you see that via has gone off, right? That's okay. Now I can do one more thing. I can move this block. Okay, so I can move this block up here, right? I made a copy of it, and then I can move it 0.25 here, so I can place one more via here, right? So I can say edit, move, relative, and I would say 0.25. Okay, so I think that would be the center, right? So what I'll do is I am going to copy all these vias. So I'll just select them with a shift key down or control key down. You can select all of them. Okay, maybe I don't need that, and I can just create a copy, and I will copy to the mid of this. Okay, doesn't matter, roughly it doesn't matter. So I have placed zigzag vias like this. Get rid of this, get rid of this, and I can also get rid of this line if I want. So let me do an undo on this one. Okay, I need this part, so I'll show you why I need this part. Okay, I moved it back. Okay, so I don't need this line anymore. Okay, my vias are placed, and the last one I can get rid of, and probably I don't need this one also. Okay, so this is done. Now I can grab all these like this, pressing the shift. You can also select like this with the shift pressed, and it will select all of the vias. Now I'm going to make a copy of this. Okay, anywhere you can keep. Then I'm going to do a mirror of that, right? And then I'm going to copy that, move that from here to this corner. So I have created a symmetric structure around this of via and get rid of that and that. And you see my vias are tying the coplanar grounds down to the ground on metal 6. So this is a structure of a coplanar waveguide, and I'm expecting that everything is okay to give the right 50 ohm impedance, right? So now I'm ready to put the ports. So I will go to the center. This is pin 1, this is pin 2, this is pin 3, this is pin 4, and the pins have to be in the right metals. So the ground is actually on metal 6, right? So I'm just going to move this pin from here to here, and then I'm going to move this pin from here to there, right? So now we are done with the ports, so I can set up the EM simulation, okay, and say okay. And first of all, I'll go to ports and open a port editor, and I would say 3 is a ground reference for 1 and 4 is a ground reference for 2, same way as I did for microstrip line, right? And once the placement is done, I can do a 3D EMPro view because the setup is present now. So once you click that, it's going to come up with the EMPro view. So you will see how a 2D structure can easily be created, and then it can be transformed to a 3D structure automatically like this. And let me just make sure they are shaded. So this is shaded, this is shaded, and this is shaded. Okay, so now you can see that this is the center conductor, and you have got the coplanar ground. So you can see these two yellow ones are coplanar ground, and the red one underneath is the ground, right? So the line is surrounded on 3 sides with this conductor, which is ground. Correct. So I guess there is no problem in understanding this. Now, as far as connectivity is concerned, all the grounds will show up if I select this one. Yeah. So you see, this solid connectivity tool is saying that the center line is not connected to the ground anywhere because it is transparent, while all that is translucent is basically one piece electrically. So that makes sure that my vias are placed correct and my line is not shorted out. Now if I was to do the same thing with the centerpiece, then you see that centerpiece is shaded while all others are not shaded, right? So that just shows that, you know, the line is not shorted anywhere, right? So this is the 3D EM preview. So now we are ready for simulations. So I'm going to go here, first make sure it is a momentum microwave. Look at the substrate, which is correct. I'm drawing on M7 and M6, and I'm using VR6 in between. Then ports are okay, reference properly, and then I'm going to do a single point simulation at 10 gigahertz. Right, so that's the 10 gigahertz. I'm going to save the currents at all the frequencies, and I'm going to mesh as edge mesh, transmission line mesh. And once you're done with that, you can go to model and say ensure that model is created, and now you are ready for simulation. So you just hit simulate. Substrate is already computed at 10 gigahertz in the previous exercise, right? So it's not going to compute the substrate anymore. It's going to mesh it right away. So once it is meshed, you see it is meshed now. Okay, so this is meshed, and now it is doing the simulation. Okay, and I think in any time soon this will be done. Okay, so that's your done. Okay, don't worry about this one. You just find an empty space, plot S11. So unless I've goofed up, S11 should be 50, and that's close to 50. It's much better control compared to a microstrip, right? So if I put here a marker and I normalize to 50, so if I go to format, normalize to 50, it looks like 48.8 ohms, so which is close to 49 ohms, right? Now if you want to do the jugglery, if you want to increase the impedance, then what you can do is you can reduce the width of the line, and the gap will increase slightly, width will go down, and the impedance will go up. You can make it exact 50 if you want, but I'm not going to do that exercise. So if I look at S22, it's doing the same thing. Okay, it's over here, it's almost 50. And if I look at phase of S21, which will tell me the electrical length, so if I plot the phase of S21, okay, so that is 90 minus 90.4, so that's a 90 ohm line, no, so 90 degree line. Okay, so in momentum it is very easy to do a layout. Now same thing if I do in a 3D simulator, it will take more time, but then all the Keysight users have an advantage. Okay, so what's the advantage? Let's see that. You go to the EM simulation setup and you just click on this button which says launch EMPro, and it will just export this design there. Okay, so now it is looking for, I think it is looking for EMPro home. So I have to, first time, only one time you have to point it to EMPro home. That's a EMPro home, right? I think it is in the bin. Or this is good enough. Yeah. So unless I have goofed up, it should be having a 3D structure for that line. So what happened? It is still doing it. Okay, so what has happened? Okay, so basically material assignment is not there, right? Ports are there. I'm going to delete these ports. I'm going to put my ports again. So I will delete these ports. Where is delete? Okay, ports are deleted. So that's the structure. Okay, there is no material assignment. I'm not sure. Okay, but why don't I see the material? So I guess it's not as good. Okay, now that means you would have to put in the material for the substrate, right? Because right now it is consuming air. All it did was took the metal, right? Let's see, what is this. This is simulation box. This is substrate. So this is metal 6. This is say invisible, and that's metal 7, said invisible, and that's VR. Okay, so it has put 3 layers like that. Okay, so that makes sense. What about the substrate? Okay, the substrate is not visible. So how come this is empty? Borosilicate. It's visible only, but why it is light color? Ah, so basically That visible. That visible. So this substrate makes no sense. So this is not perfect actually. This is not perfect. Okay, so it still cuts down my time of drawing this 3D structure. Okay, anyways, I'll have to remove this substrate. So I'll just remove this or delete this. Okay, so I have this structure which is metallic structure, and I'm assuming the ground reference is over here. So this is 9 micron, and from 9 micron I'll go 97 up to here. Okay, so let's look at the top view. I'll have to put the substrate in here. So here you can look at the top view and say view all. Okay, that's strange. Oh, I can't make out what is what. Okay, anyways, top view, view all, and via 6, and so let's select these. This one, and if I press Control, I can select this one, and I can select these ones, and I can select this one. Okay, so this is one piece of conductor, and so I'm not going to merge them right now. View all. Okay, first of all, I'm going to draw this will come to later on. Okay, so these are the snap options here. Snap to grid. This is snap to intersection of grid with the edge. This is snap to vertex. This is going to be snap to edge. This is snap to intersection of two edges, right? And this one is snap to a cross section. Okay, so this, if I put as 9 micron, so usually you do not have a control how it is going to locate this in a, okay, so locate this in the whole context of this. So I'm drawing this. So why I'm not able to snap? So did it do the center thing? UV 0.125. Why is it doing a grid like that? So this, okay, you can put a tab here. Width is 4, height is 0.4, 0.5, 0.51, 1 mm. Okay, and then extrude 97 micron. Let's see if this makes sense. 97. Now will it be 97? This is at the top. This is at the top, right? So it will be 97 micrometer. Okay, and see done. So let's see what it has done. Oh, the height was also wrong. So that's the problem with the what you call the export. It doesn't always turn out to be right. So this is not going to be much of a help, right? This is not what I expected, right? Okay, and I should know what is the distance between here and here, and why it is this much down. No answers. So basically one single click export is not working for me. Okay, so you don't have to bother about this. We will redraw this line in EM simulation here. Okay, so I'm going to talk about EMPro from this point on. But you have realized that if I was to draw this, okay, this will be very much very much involving, right? And this comes as assembly. So let's just close this. Okay, I just don't like the way they have just exported that. Okay, so we have a geometry here, and we have done something like momentum simulation. We got the length right, we got the impedance right, and the structure looks okay. So now we are going to start with momentum. So you understood, it is easy to do the 2D structures. Okay, so let's try to do this with EMPro now. Okay, so let's not mix the two. Okay, so let's close all this stuff. Okay, only thing I need is this. Okay, so you launch EMPro. So I'm not going to do the line right away. I want to introduce you to what is EMPro. Okay, let me see how much time has gone into this. 37 minutes. Okay, so I'm going to make a new project. So as soon as you launch EMPro, this is a getting started window, and there are some templates available here. So I'm going to choose a millimeter wave mm dimensions in mm. I'm going to choose FEM simulation, right? So that's a template which is available, right? And then I am going to do set the minimum maximum frequency. Okay, let's put maximum frequency to be 20 gigahertz. Okay, doesn't matter, you can change them later also. Okay, so you can click OK. Okay, and you can just cancel that. So now you have a blank space to draw. Okay, so now let me introduce you with this window. Okay, so this is a multiple document interface window. Okay, so this is the mother window or the parent window, and everything inside is a child window. So you can basically just move that around. So this is a child, it cannot go outside the extents of this GUI. You can double click it and you can reduce it. So this one is called geometry, and I'm going to draw my geometry here, right? So this is why it's called geometry, and these are called primitives. Okay, so the way to do it is you create a project, very simple. Okay, as soon as you create a project, it is not named yet, so that's why this is a project tree here which says the project is not named yet. So I'm going to go to this file and say save as, okay, or save project, and then this comes up here, and I have two options here. One is called open access project, other is called legacy project, right? So that QFN was a legacy project, right? And this open access means that the database connectivity can be there between various tools which are supported by Pathwave. So that means that if you want a connectivity between the designs done here and the ADS, it's better to keep it as an open access. Okay, now next is save project as, and this one is called a library. So basically you can add a project to or multiple projects to a given library. Okay, so let's name this project. Let's say this is a CPWG50. So that's the name of the project, and it is not giving me a choice of open access library. It's not giving me a choice to do that. Okay, so this is the path, this is the browsing. It should allow me to do the library, isn't it? It should allow me to change the library here, right? Okay, maybe we'll try to see if we can add this cell later on to a different library, but this should be active, right? So anyways, so I'm just going to say save. That's there. Now can I change the properties? File, edit, project properties. Okay, display unit, advanced. So this has to do with the grid. So these are your display units. Okay, so I'm not going to change any of this stuff. I'm just trying to figure out where I change the library. What it says, view libraries. This is a library view. This is your basic components for ADS. Open access library. So I'm not going to mess up for now. Later on I will see how to add cells to libraries. So we are done. The project gets a name, and then we can draw the components. Okay, so now my idea here is to introduce you to this EMPro. Okay, and so as I told you, it's a parent window, and every window in the center space is going to be the child window. So that means that you cannot take the child out of the parent extents. Okay, now on the left hand side, this is called the workspace tree, and the project is named at the top. Now in the parts is whatever you draw here, that's going to be added to parts. Okay, you can make a new assembly, so your parts can be combined into an assembly, right? But I'm not going to go into that for now, for ease of learning. Then you can have circuit components or ports, right? So basically, like for example in ADS we did port 1, port 2. Similarly here I can do ports. Okay, then I can have external excitation coming as a file as an input for excitation, so don't worry about that. Go to sensors. Unless I'm putting sensors are basically collecting the field information, so those are the sensors, right? So I'm not using sensors anymore here. Then we have got definition. Now in definition we provide a definition to the instance. So for example, if I was to add a bond wire, okay, the bond wire will be referring to a certain model, right? So that definition would be that model, and the bond wire would be an instance of that model which shows under part. And whenever I want to apply that model to that bond wire, I have to just drag that model from here and drop onto the instance. So that means I have applied a model from definitions to the instance in the paths, right? So it will become clear once we start drawing, right? So you have got materials. So in this case, okay, perfect electric condition, that's the bottommost. Metal can be, but it can be a metal also, it can be a sheet, which is perfect electric. Okay, now free space is everything is free space. Once you draw, then the free space is taken away by whatever you draw. Okay, so that's what the material is. You can right click and you can add new definition of a material. So it shows up as a new material. You can say for example borosilicate. Okay, so that's a borosilicate, and if I double click it I can add properties to it. So it's a non-dispersive. Okay, I can choose the entry method to be loss tangent and dielectric constant. So dielectric constant is 5.85, right, and the loss tangent was 0.002. That's done. and there are other materials which can be chosen, right? So for example, Debye, Drude, Lawrence, right? Sampled, nonlinear. Okay, now some of them work for FEM, and some of them work for FDTD, and some of them work for both, right? It can also be a magnetic material here. Okay, so you are not going to deal with all this stuff, right? So you don't worry unless you do a substrate which is, you know, kind of non-dispersive, and then you can do an isotropic material, or you are going to do a polar material. But this is non-dispersive, which means that it is frequency independent, right? So appearance, you can make it look like gray color, for example. Okay, so I can make it look like this color. Okay, then I can put the edge color. So just 1 second. So why can't I do the blue one? That's strange. Okay, let me move this. Okay, so it's darker shade. Vertex color, let me move it. Sorry. Come on, why do I have to struggle this much? Yeah. Okay, so you know, this is certain shade which I have done. So done. Okay, so that's there. So how will I draw? Okay, so my drawing tools are over here, and there are some 3D primitives are there. For example, this is going to be a solder ball, right? This one is a trace, this one is a bond wire, this one is a cuboid or a box, this one is a sphere, this one is torus, this one is prism, this one is pyramid, and this one is cylinder, this one is a cone, this one is a spiral, right? So all these primitives can be used for drawing, but you can always do the drawing like you can do a 2D just like in ADS, and then you can provide it an elevation, right? So that's what you can do. You can do a 2D and then an elevation. Okay, so that's that, and we will see different forms of, you know, elevation with a certain draft. Okay, you can make a cone or something like that. So this is along Z direction, so you take a 2D drawing, and then you can basically extrude it in the Z direction. So that's what that extruded. Or you can do a 2D drawing and then you can revolve it, okay, rather than extruding in the vertical direction. So that's that. Okay, here you can make you can have an already existing body, and then you can take the face of the body and extrude something from there. So that's that. Or revolve something from the face of a body. That's that. Then you can do a sheet body, which is infinitesimally thin body. It doesn't have a thickness, right? Or you can take a 3D object and just convert it into sheets, right? So it can be made up of sheets. So we will see that. Now this one is a wire body. Okay, so you have these options. So the most commonly used one is the extrude, right? Then you can do this primitives, which is a trace and all that. Now once you are drawing, you can modify the geometry by using some of these functions. So we will see that later on. And then over here you can combine two bodies like union, subtract, intersect, right? And this is going to be your chop. Basically it is going to be intersect plus minus. So minus this or subtract plus intersection is going to be chop. So you are going to use this chop a lot, right? And then you have got certain modifications to the object we have done. You can scale in X, Y, Z whatever you have drawn, You can translate what you have drawn, you can revolve what you have drawn, and then you can also do multiples. Like for example, you can make an array out of, so you can reflect it, you can shear it, but then you can also make, modify or transform. So that's that. You can also make patterns out of it. So we will see all this stuff. So to draw this, first thing is you have to extrude it, or you can say create geometry extrude. So this is from the menu, or these are the buttons in the toolbar. So they are most often easy access, right? You can just, instead of going 2 clicks, geometry and extrude, you can directly extrude. So all this I have already explained you, right? Then you can add circuit components, so which you can add over here also in components, circuit components, right? So that's there. Then you can add sensors also. So sensors, for example, you want to collect the field data in an antenna, you can do that. So these are this is a toolbar for drawing, which is a part of a window called geometry, right? And this is a menu bar for that. So all the most commonly used shortcuts are in the toolbar with the click of a button, or you can use the menu to do that, right? So Boolean operations are listed here, while Boolean operations are shown here also. Okay, view. Now when it comes to view, you can look at the side views, top views and front views and back views, right? So these are along different axes, right? So right now I'm looking at X and Y axis. Okay, so you can see this is if you go vertical, that will be Y axis. If you go horizontal, that's X axis. And then if you come out of this screen towards you, that will be the Z axis, right? You can always rotate this to see this, right? You have got X axis, Y axis and Z axis. So your view basically is deciding that. So if I put a top view, I am looking at XY plane. Okay, if I go to the front view, I'm looking at XZ plane, and I'm going to be progressing along Y plane, right? So if I want to draw in XZ plane, I can use that, right? Or I can do a side view, which is a left or a right. Okay, so that will be YZ plane, right? So I'll be drawing in the YZ plane and then extruding in the X direction. So most commonly used is going to be the top view, which is going to be the drawing in the XY plane and then extruding out in the Z plane. So that's the top view. So you can always change the view here. Now these are called isometric views. So basically you can see all the sides, whether it is front, side or top. You see equal proportions of that. So that is called isometric view. So there are different angles from which you can look at your drawing. Okay, front, right, top. Okay, so front right top would be an isometric view. Front left top will be another, you have rotated the object, you are looking at it from a different direction. So these options are available here. Now here you can add your custom view. Okay, so that's that. And here you can cut the objects and look at that. So we will see this later on. Now this one here, it says measurement. So just like your measure, right click measure in momentum, you can measure between the two edges or between two vertices. In 3D you can measure using this tool, right? And then this is the solid connectivity tool, which you have already seen in momentum. So that's that. Okay, field radar. So basically you can pick a test point in the field and look at its values. Okay, now here this is a visibility toolbar here on the right hand side. So you can take an object and you can make it transparent, right? So that's that. Okay, you can make a component visible, you can make sensors visible, then you can make the fields transparent or visible or invisible, right? So that's that. You can look at FDTD mesh, right? This is bounding box. You can look at the bounding box, or you can see, or you can change the bounding box also. So that will come under simulation domain. So it says boundary conditions. you can choose different boundary conditions for FDTD, but this is a FEM simulation here, right? So that's the template. So once I do I can change the boundary conditions here. Okay, then in case of FEM you are doing padding. Okay, so padding is basically deciding your box size. Okay, so we'll go into that once we draw it. Now if you want, you can write a Python script to automate some of these settings, right? So that will be the scripts. Now if you want to plot something, that would be a graphs, the same as the data display window in Momentum. It will be called graphs here. Then these are called groups, so you can create groups of objects, group of scripts, group of sensors, group of models or definitions. So you can make groups out here. Okay, so this is your project tree, which I am trying to explain here. Okay, so enough said. Let's draw that coplanar waveguide. Okay, so that's the exercise which we are going to do. Let me see the time. So 56. So 20-25 minutes we should be able to get that thing going. So okay, so this is about broadly about what is what over here, and there's something over here which I will show as we go ahead, and then there's something over here which I will show as I go ahead. So I'm not going to just do a description of everything and then you will not remember anything. Okay, so I'm going to draw in X and Y plane, so that's clear. And if I do a extrude, right, and here first of all, what is the orientation with respect to the global coordinate system? So the origin is at 0, 0, 0 mm, right? And then I am going to draw in the Z, extruding in the Z direction. Now you can extrude in any direction, so in that case you would have to specify here. Right now this is all disabled, but then you can specify these. Let me see. Okay, so this will come to later on. So for now, picking tool, alignment tools, presets. Okay, presets is your plane, so you can choose X and Y plane, you can choose YZ plane, XZ plane, so plane in which you are drawing. Okay, and the origin is at 0, 0, so I am going to keep the origin same. First of all, I'm going to draw the ground. Okay, so this is a drawing toolbar. So here I can make it. So what I'm going to do is I'm going to do a 2D drawing on this surface. So there's a 2D drawing which I can do here, right? And so that 2D drawing can be done using these lines, polylines, and then these are perpendicular lines to a edge, or it can be tangential to edge. So these are your lines. Then you can do squares and rectangles or polygons, right? So you can do, as we go ahead, I'm going to show. Right now we are interested only in rectangle. Then you can draw an arc. Okay, so there are different ways of drawing arc. Then you can draw a circle. There are different ways of drawing a circle. So once we do the vias, we will use this circle. Now these are called constraints. So this is a horizontal constraint. That means your lines are going to be all horizontal. Whatever you're trying to draw, it can only draw horizontal. Okay, so this is a horizontal constraint, this is a vertical constraint, this is a collinear constraint. So that means if there are two lines, you can put a constraint on them that they are going to be parallel to each other, right? So they can be parallel, right? They can be perpendicular, they can be tangential to edge. The circles can be concentric, right? Or there may be a fixed angle constraint between two lines. So these are your constraints. Okay, similarly here, these are the distance constraint. So between two lines I can fix the distance, or I can have a length constraint, right? Okay, I can have equal distance constraint. So these are those constraints. Now with the circle, you can have a concentric circle. Okay, you can have a circle with equal radius. Okay, so these are there, and then you can lock the position of a component which you have drawn. So these are the constraints. So as we go ahead, we will see these constraints. And this one basically is if you want to take a corner and chamfer that corner out. Okay, so that's for that. This one is basically going to be insert a vertex. So if there is a line, I can insert a vertex in between that. This one is basically when two objects intersect, I can delete some of the internal boundaries. Okay, so now to be able to extrude, one condition is there should not be intersecting areas. Okay, that's one thing. Okay, and then the area has to be totally enclosed to be able to extrude. You cannot take an arc, for example. Arc is not a closed body, so you cannot extrude from an arc. Okay, you cannot extrude from something like which is the two areas are overlapping. You cannot. And if you do that, there is this warning which says that you have done something wrong. Okay, you can give the name to the object which you're drawing over here. You can undo what you have done in this session of extrude, right? So let's say I want to draw a ground plane on metal 6. Okay. Okay, now I remember what is happening with the okay, why the thing didn't turn out correct. Okay, because if you remember, our substrate definition in momentum was from metal 0, and then we went up to metal 6. So that's why your orientation of that object was on metal 6. So that height was the reason why it was up there. Okay, so if you refer to this video back in time, you will see that the object was drawn at a certain height. Okay, we will try this attempt again, but for now I'm trying to teach you how to draw directly in EMPro. Okay, and these are the snap options: the snap to grid, the snap to intersection of grid with the edge, snap to corners, snap to edge, snap to intersection of two edges, right? A step to cross section. So these are your snap options. So very simple. On metal 6, if I want to draw, so I will start with 0 0. So you can see where your mouse is. It will show here 0 0 if I go to the center here. So that's 0 0. Then I can basically, so this is a 2-point method to draw a rectangle, right? So first vertex and then the diagonal vertex. So the diagonal, I can always put a tab. So if you put a tab, then this appears. So here I can say that the width is 4 mm. So if you remember, the length of the line was 4 mm, so that's over here. And the height is going to be 1 mm, right? Okay. So once you're done with this, you say okay. So that's your ground plane. And then you can say extrude, and you want to extrude 9 micron. Okay. So if you extrude 9 micron in the Z direction, so you see the direction here is Z direction. Okay, so then this will look like a sheet of metal, right, which is 9 micron thick, right? So this is understood. There's nothing wrong with the geometry, so there is a green indication here. Now I can call this name as a GND. Okay, so that's a ground. You can name anything and you can say done. So you can rotate this and see what you have drawn. Next is I'm going to put here the substrate. Okay, so I can go to the top view, I can center it out, and the substrate is going to be again drawn from the same corner, right? But this time this has to go 9 micron up because you do not want overlapping bodies. So 9 micron up is my center. Okay, and the cross section is going to be the same thing. You start with 0. Okay, so you start with 0, and then you press the tab button and you say the width is 4 mm and the height is 1 mm, and then you say okay. So that's drawn here, and then I'm going to extrude by 97. Okay, and I will call this one as sub. Now if you want to see what it has drawn, so over here I can move it. So you see we went 9 micron and our origin was here. So we went up 9 micron, and from there we have drawn this box which is 97 micron, okay, on top of it. So basically that's my metal 6, and this one is my substrate, okay, and I named it sub, not sum. Okay, and say done. So now I have this sitting on that. Next thing is I'm going to draw the vias, okay. So now here you have to have certain calculator in your mind, okay. So if I go from here 0.4 micron, that would be the edge, right? And that means I have to go right by 0.1 and down by 0.1, so that will be like 0.3 over here, and on the height 0.3 and 0.1 on the width side. So what you have to do is you are going to draw a circle, right? But then orientation you will put here 9 micron because you are drawing on the same level as the substrate. Okay, so once you are done with that, okay, then you can choose this guy and you can right click once. It hasn't done anything, but then you can press tab, so it will say where you want to keep the center. Okay, so I want to keep the center at 0.1, okay, and this one I want to keep at 0.3. okay, so this is over here somewhere, okay, and then the next tab would tell what should be the radius. So I'm going to put this radius as 0.05. Okay, so now you don't see that, but that's green, and I will call this as via 1 or via set 1. Okay, and say done. Now to see that, that's basically embedded inside this substrate, right? So I can make this substrate invisible, set invisible. Okay, so now you see that this via is sitting on this ground, right? So this via is sitting on the ground. Okay, so if I say top view, view all, so that's the story here, and I got to repeat them this way. Okay, so with a gap of 0.5 I have to repeat them, and then I have to also repeat in this direction. Okay, so I have to make an array of it, right? So in this direction, how much do I go? So basically the center is 0.1, 0.5, so 1.15, then again 0.1, 0.25, then 0.3, and then again 0.1. Okay, so it will be 0.4. So what you do is you select this one and you go under modify and you go under pattern and say linear rectangular pattern. So here I want 2 rows, and I want 2 rows, and this one along V is 0.4 mm. Okay, along Z is going to be, doesn't matter because I'm going to put here 0 or 1, I think. So this one will make no sense. Okay, now here 0.4, and then this one is 0.1, 0.5, right? So we did a 0.5 the last time, 0.5. Okay, and I want to repeat it. So how many do I want to see along the length, the width? Let's say if I put here 5, so that comes up to here. Let's put here 8. That's over here, 8. So 8 is a good number, right? So if you do that, you can see that you have drawn 8 of these, right? Okay, so you have drawn 8 of this, and say done. Okay, so now I am going to put stack, right, again here, Okay, so I will just do a 0.5 below, and this one was 0.1 and this is 0.5, so 0.35. Okay, so the other set of vias will come 0.35. So go at the top, and if you want, I can make this one also invisible so that you can clearly see it. Right, so I want vias here, 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 here. Right, so I have to follow the same procedure. Okay, I want to set first of all the height to be 9 micron, right? And then I go to cross section. I want to place, so right click anywhere and then press tab. Okay, so I want, right now it was 0.3, so I'm going to have 0.25. Okay, so this y is going to be 0.25. Okay, and then this is going to be 0.35. Okay, and when you click OK, you will see that this is somewhere in the center between the two. That's how we were staggering it, right? And then if you press tab again, I want to keep this to be 0.05, sorry. Okay, and then extrude it by the same 97 micron, and this I will call as via 2. This is a via set 2, and say done. So now I'm going to repeat this. So let's do a view all. So I'm going to repeat this on the upper side also. So I'm going to say this one. So I can go here, modify, and say linear array. Okay, so right now I have to go up by 0.5. Okay, so now this is done, correct? So I have created the same kind of a staggered structure which I did in momentum, right? These are my via sets. I can say done. So my vias are done, right? So I can now go and draw the top plane. So if you see the top plane, 0.9 has gone into the ground. 0.97 9 micron has gone to the ground plane, and then 97 micron has gone to the substrate. So now I'm going to do one more thing. This substrate is there, right? So I'm going to make this visible. Okay, and these are embedded into this substrate. So you cannot have overlapping regions, or you cannot have overlapping areas. So what am I going to do? I want to keep the substrate, so I'll select that first. Then I'm going to press Control and via 1, and then I'm going to say chop. And once I say chop, so I have created here 2 of these. Okay, so one is called sub, and which is the intersection. So just looking at this, you can say that this is the intersection and this is the minus. Okay, so the minus remains sub, while the intersection becomes, rename it to via 1. Rename it to via 1. So now you have made sure, not 2. Now you have made sure that you have got non-overlapping regions. So what happened? I rename it to via 1. So why it's not taking via 1? Rename. So let's make this via. It's not taking. For some reasons it's not taking a different name. Okay, we will see this later, but let's say this is invisible. So now you see what we have done. We have done the chop. We have chopped the substrate, and then we have our via also available, right? Same thing I'm going to do with this and via 2. So first I select this, and then I say Control and select that, and I say chop. Okay, so now I have chopped, and again the other set of intersection here. Okay, I'll make it invisible. Okay, so now you see that this is the substrate. right? And so this one is the substrate, so I'm going to make this invisible, and these ones are the vias, so I'm going to set this visible. Okay, so now you can see our vias are there and our substrate is there. They are not overlapping regions. Okay, so this is a valid geometry, right? Now once you are done with this, so let me just turn off this one, turn off this one, so make it invisible, make it invisible. Okay, set invisible. Okay, and make substrate visible. Okay, so now this is the substrate, and then the bottom layer is the ground, so let's make this visible. Okay, so now what you see here, this one is your ground, this one is your substrate, and then you are going to draw the coplanar ground, right? So if I say view all, so I'm going to put a line and a coplanar ground, so that would be very simple geometry. All you have to do is this, and you have to put here, so that will be 9 micron plus 97, so it will be 106. Okay, so this will be 106 micron. 97 plus 9 is 106. Okay, 106 micrometer. Fine. And edit cross section, I'm going to draw all the three now. So first of all, I can right click and tab, so I'm at 0 0. Okay, and then I will go up to 0.4 here, so I will tab again and I will say I'm going up to 0.4 and say okay. So this is 1. Okay, at the same time I can go 0.4, right? So now I can put a tab here, so right click tab, so my origin 0.4, 0.5 and 0.6, so 0.6 is my origin here. Okay, 0.6, and say okay, and I have to draw up to here, so put a tab which is 0.4 and say okay. So these two are drawn, right? And then I want to draw the center conductor, so this will be 0.4 plus 0.5 gap, 0.05 gap, so 0.45, right? So if I put a tab, so this will be 0.45. okay, and then I have to put here again a tab and say that this is going to be 0.1, correct, and say okay. So now this is going to be extruding 9 micron, 9 micron, and this will I will call as top layer. Okay, and I can just say okay. Now our structure is correct now here, right? So let's delete the, let's make this invisible. Okay, so now you can see our structure is this, and you can make this one as visible, right? Set visible, set visible. Okay, so now you can see your vias, correct? And you can see your center conductor, right? Okay, so you have made your object. One more thing is, can I split this? Cannot split it, right? So I will go back to the extrude bar portion of this. So you can always go back, and I'll put a top view on this, and I will delete this line. Okay, so this would be problematic. Okay, so if I press delete, 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 and right inside there is one line, delete. Okay, so I will draw that separately. Okay, so the line has to still to be drawn, right? So I will extrude a separate body. Okay, so extrude again, and this is going to be 106 micron, 106 micrometer. Okay, and this one is going to be a rectangle. I want to draw somewhere here at 4.5. Okay, and then I'll be drawing up to here. Again, tab. This is going to be 0.1. Right, and say okay, and this one I'll call as line. Right, and extrude by 9 micron and say done. Okay, I wanted to separate them out. Now you see what I'm going to do. I am going to take the ground, and with the control pressed, right, I'm going to choose two sets of vias, right, and I'm going to choose the top metal. So this is the entire ground structure. So I have chosen all of them, and I'm going to merge all of them as a single object. So this is my ground now, right, and this is my substrate, and this is my line. So my drawing is done. Now I have to do a material assignment. So I have already declared borosilicate, so I can take this borosilicate and copy it to sub, and I'll make this sub as visible. Okay, so now you can see that this is my substrate. Okay, now I can add metals. So I can go to material, I can say select from library, and I can select silver. AG is silver. Okay, and just say add, and this silver I'm going to copy to the ground, and the silver I'm also going to copy to the line. Okay, so now you see my coplanar waveguide is done. Okay, now I have to do the ports. Okay, so to do the ports, what I have to do is, first of all, I'm going to right click on this and say add waveguide port, but somewhere I'm going to just cancel it out. So what I have done by that process is I have added under definitions, under circuit components, I have added the waveguide ports. Okay, now I am going to right click again and say port with no definition, and here I am going to draw the extent of the port. So basically this is my ground position. So once I click on this one, I will go to the center of this, click there, and then this one I'm going to go to the center of this and click, and then to the properties I will call this as port 1, and over here I am going to say this is a 50 ohm port. So this looks same as what you had, and extend I will say use sheet, but here I want to restrict it to this one. So basically the first one, right, so it will be 0.45. So 0.45, and why that is because I want to keep this restricted to underneath the, so in this case the port is not just the one arrow, it is going to be a surface or an extent of the port. So that's the extent of the port, and I'm going to say done. So this is one port which is done. Then I am going to go on the other side. So by the way, if you use the left mouse button and drag it, it is going to rotate, and if you use the right one, it is going to pan. Okay, so the second port I'm going to add here, say no definition. I'm going to use the first point as a center point, it will highlight by itself, and the second point as the center point, which is again going to highlight by itself. Properties, and this is going to be port 2. Okay, and this is a 50 ohm port. Extends use sheet. Now here I am, so here it has taken the entire sheet by default. Okay, so 0.45 and 0.45. Correct. So this is done. So this is the second port which is done. So I have put 2 ports now. So now you have seen what did I do. So let me make the substrate invisible. Set invisible. Okay, so now you can see the structure. Okay, so this is your ground plane, these are your two coplanar grounds, and this one is your line. Okay, and then you have a substrate which is non-overlapping, so I'll make this visible. So now we are set with the structure and with the ports. Okay, so now I'm ready to do the simulation. So here this button, so this green arrow shows that everything is okay here. Okay, it is ready for simulation, ports are okay, everything is okay. So here I am going to say simulation setup. Okay, and here this is min max frequencies. If you remember, I said 1 gigahertz is the min frequency and 20 gigahertz is the max. Okay, I can choose this to be a single point simulation, single point, and this is going to be 10 gigahertz, so I can put here 10 gigahertz. Okay, so that's done, that's the frequency. Mesh refinement. Okay, so now this is going to be adaptive mesh, it's a FEM as I told you. Okay, so I should have at least one iteration or two iteration, at least two iterations to be there, or maximum 15 iterations. Okay, and I'm not limiting the memory. Refinement. Okay, so initial mesh. Okay, advanced. After convergence, solve on the finest mesh. Okay, so that's what I have done. Then solver, I'm going to use a direct solver, not iteration. And then I have to just set up the currents, to save the currents, which should be under where? This is 10 gigahertz. Fields, storage fields, all frequencies from the frequency plan and the mesh frequency. So this is done. Okay, once you have set all this, you are going to say create and queue simulation. Okay, so this is the first simulation. It is going to try to mesh it. So it is doing the tetrahedral mesh generation, and it's going to do mesh reduction also. Okay, that's done. Now it is trying to do the adaptive meshing. So it will come up with a window which says what's the difference between the first mesh and the refined mesh. Is that's going to be a tolerance, right? So let's see. So the total number of tetrahedra are 42,282, and this is the first mesh. And the issue is delta S, so that delta S will come in the second iteration of meshing, which is going to be a finer mesh at 10 gigahertz. So that's coming up. Okay. Okay, so now you will know the difference. So that difference is 0.037. It has to go 0.01. So it will still do a finer mesh. And you'll see the number of tetrahedra and the memory is going to keep increasing. So number of tetrahedra was 42,282. Now it became 49,499. And the memory has gone up from 1.8 gigabytes to 2.3 gigabytes. Right? And the delta is 0.03. It has to be less than 0.01. This tolerance you set when you set the simulation. So now it's still 0.03, and this is now 2.7 gigabytes. By the way, the physical memory on this machine is 16 gigabytes. So if it crosses 16, then I have a problem. I have to go to a different machine to do this. So I hope that for this example at least I have this machine which can do it, and from the next session onwards I'll have a machine with a higher memory. Let's hope that it is below 16. This is because you have lots of round structures, right? So if you have something round, meshing is very dense on those round structures. So 0.01, okay, 0.014, so it has to go below 0.01. Right now the memory is 3.2 gigabytes of RAM. Hopefully this one will push it below 0.01. It depends on the luck, I don't know. Actually, meshing depends on the seeding. Okay, so the seeding is your initial mesh, so you can control that also. Okay, so next time I'm going to have a faster machine. This is a dual core. I'm going to put 18 core in the next machine. Okay, it has gone below 0.01. It has gone to 0.008. Now the mesh is done. This is already computed, so it is going to just repeat it, and it is done. Okay, it says completed, right? So this simulation is, this is going to toggle that. This is geometry, that's simulation. Now results. So this is going to be the result window. Again, I told you this is a MDI, so this is a child window. Okay, so under results, okay, so this is one simulation, one instance of a simulation, and I am interested in frequency S parameters. If I double click on this, okay, it opens this one, and I can choose the graph to be a Smith chart. Okay, and I can look at S11 and S22. So S22 is green and S11, so it is where we saw in momentum. It's almost there. You can put a marker here. So you can put a marker here, right? So that's a marker. Okay, so anyways, now once you're done with this, you can just say save the graph, file, save as. Okay, and why it says export? I should just save this graph, right? So file, save plot as graph, right? Okay, so it should show up here, right? Okay, create a new graph. Okay, and this is the graph, right? So now I should be able to put this under a XY plot also. So you see here, this is minus 29 dB, S11 and S22. I can save this also as a graph. File, save plot as a graph. Okay, so that's the second graph here. You can edit these graphs later on. Then I can also look under rectangular S21, and here I want to look at phase of S21, so I can say phase, and that's around 89.9, which is what you got in momentum also. That's 90 degrees line. So basically what I've shown you is this. I can also save as a graph. File, save the plot as a graph. Okay, we are done. We can close that. Now let's see if I can open this graph. Yeah, so these are our graphs which we just plotted. Okay, so this is how you plot your graphs in EMPro. Once you are done with that, you can go back to your results, and I want to plot the surface currents, isn't it? So this is E field. If I look at all and all, if I look at currents, component loss, power available, system efficiency, fields, surface fields. Yeah, surface fields will do it, right? That will have the current information in it. Raw data, S parameter. So let's try that. Okay, so it has opened that, and at the bottom, well, you are going to see what you're going to plot. Okay, and I am going to plot J, or surface current density, and I'm going to plot this on just these metals, right? So I'm choosing AG. So now I have AG only at two places. One is that, and I can make this one invisible, right? So I can make this substrate invisible. So if I go to substrate and say make invisible, so now you are seeing coplanar ground, and you are also seeing the line, correct? And then I am going to go to sequence 5-degree increment, and I'm going to say repeat. If I play it, it'll play only once. Let's go here. Port 1 is being excited by a single excitation. Surface current density I'm going to plot in these vectors, and here I need to say repeat. So how do I say repeat? So if I play this, so is it playing? Okay, so it's too slow, but you can see how the phases are reversing. So if I go to legend, right click here in the properties, I can change the maximum current to be 115, it says, right? So let's go to 50. Okay, and say apply. Okay, done. Okay, so I want to continuously play it, right? So where is it? Auto repeat sequence, correct. And it should do it again, right? So this is play button. Yeah, so you can see the ground currents as well as the line currents, but it is not, yeah, it is auto repeating. Fine. So now I can even change the legend even more. Properties, it is back to this one. Okay, so I'm going to remove the maximum part. I want to keep here 20, and why is it not applying? It comes back to this auto range. Oh, some things are not working. Application preference, absolute values. Should be able to change this one. Should be able to set 20. Why is it not letting me do this? Visible, invert color. So I'm going to put you on a pause for a second. So let me see. Yeah, I'm going to pause. Okay, so I have this stuck which says compute bounds for the playing, right? So you have to uncheck that, and then you have to set here, go to here properties, and set the maximum value, right? So that's going to be from blue to red, right? Cancel. So now you can see in animation how the currents are there in the line, the coplanar ground, how the currents are, and what's happening in the ground plane. The ground plane is almost silent, you see, almost silent, right? The ground plane is almost silent. It's the coplanar grounds which are nearer, right? So if you remember, the height of this substrate is almost 100, while this gap is 50. So the ground, the termination for E field is going to be to this ground, not to that ground. Okay, so what is significant is this gap, not the height. Okay, so that is a CPWG line. Okay, so I guess I am going to stop here, and you can visualize in EMPro the currents, surface currents. You can also look at the fields, but then when I do antenna, I will show you this. So this is a visualization window. Okay, so you can do that. Okay, so we are going to stop here. Thanks a lot. This was an introduction to EMPro. We could not do a one-click button drawing or one-click button transfer of a design from the ADS to EMPro because we were drawing on metal 6 and 7, which are kind of at a height. Okay, so we had to make a correction for that. So in some later designs I'll show you corrections. There's nothing wrong with the one-click functionality which Keysight has provided. It's just that my definition and my drawing, okay, I have to be aware of what layers I'm drawing on, right? And accordingly I might have to do some changes once I come to EMPro. Okay, had it been just the two metal layer, okay, it would have been a one click of a button. I wouldn't need to do anything. So here I have drawn from scratch a coplanar waveguide, simulated it, plotted the graphs. Okay, so you can see the graphs which I have plotted, right? Okay, and that's the phase. So that's where I'm going to stop here.